Welcome to your pre-algebra recording for the week of January 26. Please remember when you go to do the key phrase assignment, it should also match the date of this recording, the week of January 26. I thought I would share a picture of spring since the next couple days, it's going to be very spring-like, so I couldn't help but get back into that feeling of spring. It's going to be warm the next few days. All right, so let's do some review of some exponents to get started, warm us up. Remember that it is required that you are taking notes as you are watching these recorded sessions. If I were to meet with you and ask to see your notes for the recorded sessions, you should be able to pull your notebook out and show those to me. So please make sure you're taking notes. That way, when you go to do this week's assignments, you will also have something to refer back to help you. I can promise you, if you're taking notes, you are going to remember the concepts and learn them a lot better than if you're just passively watching this recording. So that's why it's required that you are taking notes. It is required. So if you don't have your math notebook, go ahead and click pause so that you can go grab your math notebook. And I would also like you to try these two warm-up problems on your own right now. The first one, you've got -8 squared. Remember that negative is not in parentheses, so that's your hint here. And then number 2, I want you to rewrite 8 times a to the -3 with only positive exponents. So remember how you move things around so that the exponent can become positive. Go ahead and click pause now, and then when you're ready to check your work with mine, click play. Number 1, that negative is not in parentheses. So really what we're squaring is that 8. So what we really have going on here is that negative is going to stay on the outside, and we're taking 8 times 8. 8 times 8 is 64. And then we've got to apply that negative from the outside of the parentheses. So our overall answer is going to be -64. And the whole reason that the answer is negative is because that negative is not in parentheses. We can look at how it might look differently if we had -8 squared, which would tell us that -8 is attached to that, or that negative sign is attached to that 8, where we would get that positive answer of 64. So you can see, depending on if there's parentheses or not, we get a very different answer. So just to review that concept. And then number 2, 8a is attached to the -3. The 8 is just being multiplied, so it's not attached. So the only term that we need to move is this a to the -3 to make it positive. So remember, to make it positive, we just move that a to the -3 to the denominator. And when we move it to the denominator, the bottom of the fraction, it's going to become positive. That 8 on our numerator isn't going anywhere. The 8 is not attached to the -3, so it's going to stay on our numerator. So our final answer would be 8 over 8a to the +3. All right, moving on, I'm going to go to the next slide. So if you need to finish up taking notes, go ahead and click pause now. So I'm going to move on. This week, we're going to focus on scientific notation. So this week is all about scientific notation. We're going to learn what it is, how to read it, how to write it, how to multiply it, how to divide it, how to add it, how to subtract it. So all focusing on scientific notation. So scientific notation is just a way for us to write really, really big numbers or really, really small numbers so that we don't have a ton of zeros. And it makes it easier to write numbers that are very big or very small by using scientific notation. So here's an example of a number in scientific notation. 5.67 times 10 to the 5th power. If we were to write this out, this is the same thing as saying 567,000. That's the same number. It's just written differently. It represents the same quantity. Again, it's just written differently. So we've taken a very large number and put it into scientific notation. So scientific notation, let's talk a little bit more in detail about scientific notation. So in order for a number to be correctly written in scientific notation, the following things need to be true. The first thing, the coefficient, this is our coefficient right here, the whole number that's being multiplied by 10 to whatever power. This is your coefficient right here. This is our coefficient. So the coefficient must be greater than or equal to 1 but less than 10. So the coefficient has to be 1. The coefficient needs to be greater than or equal to 1 but less than 10. Needs to be less than 10. The base, so what is the base? The base is this right here, the 10. This is your base, what's being raised to whatever exponent. That's your base, and it always has to be 10. So the base always has to be 10. Whatever we're multiplying by the coefficient times, that's got to be 10. And then the exponent is this right here. That's your exponent. The exponent must show the number of decimal places that the decimal needs to move to be in standard notation. And we'll talk about that more in depth here. But I just wanted to make sure we know what each of these terms represents. So I can go back and label these. This is our base. It's always got to be 10. And then the coefficient always has to be 1. Anything greater than or equal to 1, but it has to be less than 10. So this is our coefficient. So in order to be written correctly in scientific notation, those things need to be true. So let's look here. Let's see if these are correctly written first. 6.03 times 10 to the 7th, is this written in correct scientific notation? Well, our coefficient right here is greater than 1 but less than 10. So that's an okay coefficient. Our base is 10. So we're good to go here. So it says change this number in scientific notation to standard notation. And standard notation is just your whole number written out with the zeros. So how do we do that? So let's look here. We've got 6.03 times 10 to the 7th. Our exponent is positive. If the exponent is positive, it tells us how many places to move the decimal to the right. And that's because the exponent is positive. We're going to move the decimal to the right. So what do I mean here? We've got, I'm going to move this down so that, oh, actually, let me rewrite that. So we've got 6.03 times 10 to the 7th power. The 7 is positive, and it tells me I'm going to move this decimal. Here's my decimal right there. I'm going to move that decimal 1, 2, 3, 4, 5, 6, 7 places to the right. So I'm going to go 1, 2, 3, 4, 5, 6, 7 places to the right. I'm going to move my decimal and write in a new decimal. Then I'm going to fill in zeros to write it in standard form. So 6.03 times 10 to the 7th is actually equal to this number, and I'm going to put in commas. Looks like we've got 60,300,000. That is what 6.3 times 10 to the 7th equals when we write it in standard form. So again, because of the positive exponent, we move the decimal to the right 7 places. We move the decimal to the right 7 places. So here's another one for us to try. We've got 5.02 times 10 to the 3rd. How are we going to change that to standard form? How do we change that to standard form? Well, we take our decimal, and because our exponent is a positive 3, we're going to move the decimal 3 places to the right. So again, since it's positive, we know it's a big number. We know it represents a big number, a very large number. So we take 5.02, we take our decimal and we move it 1, 2, 3 places to the right, and we enter in a 0. We fill in a 0 there. So we get 5,020. That's what that 5.02 times 10 to the third is in standard form. Okay, I'm going to move to the next slide. If you need to take notes, continue. Click pause. All right, so look here now. Look at number 1. Look at our exponent. Our exponent is negative. When you have a negative, I'm going to not write all that out. When you have a negative exponent, you're going to move the opposite direction. You're going to move the decimal to the left. We're going to move the decimal to the left now. So here we've got 5.3, which our exponent is greater than 1, but less than 10. So we're good. It's written in correct standard or scientific notation. We're now going to move our decimal to the left. So we start with where the decimal normally is, where it originally is. We write the number as is, the coefficient. Then we're going to move that decimal to the left now. So let's go ahead and do that. So to the left, 1, 2, 3, 4, and I write my new decimal. And then I fill in zeros between each little arc there. So 5.3 times 10 to the negative 4th is really this small number right here when we write it in standard notation. This is in standard notation. It's just that written number out. Try number 2 on your own. Try number 2 on your own. Look to see if it's a positive or negative exponent, and that will tell you which way you need to move. So go ahead and click pause. Try this on your own, and when you're ready to check your work with mine, click play. So we've got a negative 6 exponent, which tells us we're going to move the decimal 6 places to the left because it's negative. So I'm going to start by writing out my original coefficient, 2.03, and now I'm going to move it 1, 2, 3, 4, 5, 6, right in my new decimal, and then fill in the zeros. So we've got that number really is just get rid of all the arcs and whatnot in there. 1, 2, 3, 4, 5 zeros. And then 2, 0, 3. So we got rid of our old decimal because we moved it. We moved it to the left. I'm going to go on the next slide. So if you need more time, click pause. You'll get to practice changing form. We also, this week, are going to go from standard notation to scientific notation. So here we've got a very large number, and we want to write it. So what do we have? 56,760,000,000. And we want to, that's a very large number. We want to write it in scientific notation. So remember what we know about numbers that are written correctly in scientific notation. The coefficient has to be greater than 1. So remember, the coefficient has to be greater than or equal to 1, greater or equal to 1, but less than 10. All right, so that means we really need to focus on the beginning numbers here. And where do we put our decimal so that our coefficient is greater than or equal to 1 but less than 10. So where do we need to put our decimal so that we have a number that's greater than or equal to 1 but less than 10? We need to put our decimal right between the 5 and the 6, because then our coefficient is 5.670, and that fits the bill. It's greater than 1 or equal to, it's greater than 1, but it's less than 10. And then we need to write 10 times 10. Remember, our base always has to equal 10. But what is our exponent? So to figure out what our exponent is going to be, we need to figure out how many places. So here was our original decimals hanging out at the end of the number. We don't need to put that decimal in there because we know that's the end of the number, but that's where our decimal is. So how many places do we go from here to the end? That's going to, of our number, that's going to be what our exponent represents. So we went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. So if we want to check that work, and I'm going to kind of count that out. So if we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means the exponent needs to be 10. So I want you to try number 2 on your own. So go ahead and click pause, and then when you're ready to check your work with mine, go ahead and click play. All right, first we need our coefficient to figure out what that is. It needs to be greater than 1 but less than 10. So I know the decimal has to go between that 4 and 5 to create that. So now we've got 4.5, which is greater than 1 but less than 10. Times 10, what would our exponent be? Well, how many places do we have to move that decimal? Did we move it to get to where it is? So from the end of the number to where we placed our decimal, how many places? So that's 1, 2, 3, 4, 5, 6. 4.5 times 10 to the 6. I'm going to go on to the next slide. If you need more time, click pause so you can finish up your notes. Same thing when we've got a very small number. How do we write it in scientific notation? So remember, a very small number is going to have a negative exponent. A negative exponent because small numbers have the negative exponents, large numbers will have the positive exponents. So we need to figure out what our coefficient is. And remember, our coefficient, we're focusing on these numbers here, and how can we change that so that our coefficient is greater than 1 but less than 10? Well, if we plop our coefficient right in here, we're going to have the coefficient. So it's going to be that is greater than 1 but less than 10. And then we got to figure out, well, where we plop that exponent, or I'm sorry, not the exponent, where we plop the decimal, how many places did we move between where the original decimal was to where we moved it? So how many places? 1, 2, 3, 4, 5, 6, 7. So our exponent is going to be -7 because remember, we're representing a small number. So I'm going to have you look at number 2 and try that on your own. Click pause, and then when you're ready to check your work with mine, click play. So first we need to figure out where to put our exponent. We've got 42 here, so that exponent needs to go between the 4 and the 2 to create that coefficient that's greater than 1 but less than 10. And then we have to figure out how many decimal places did we go from where the original decimal was to where we just placed our new one. So 1, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And again, because it represents a small number, it needs to be a -6 exponent. I'm going to go to the next slide. If you need more time, go ahead and click pause to finish up your notes. And then we're done. I'm going to stop here. That was just an introduction. You are going to continue this week to learn about how you add and subtract coefficients, or I'm sorry, numbers in scientific notation, as well as multiply and divide. You're going to I didn't want to go too long for the recorded session this week, so I'm going to save that piece for you guys to take a look at on your own. And if you have any questions or need any help, please let me know. So we are ready for the week of January 26th, the key phrase assignment, how you get your credit for watching this full recording. Make sure you took good notes. Explain what or how the coefficient in correct scientific notation needs to be written. That's what I'm trying to get at here. Explain how the coefficient must be written to be in correct scientific notation. So we talked about explain what it needs to be or how it needs to be written, the coefficient. Explain how, not really what, explain how the coefficient must be written to be in correct scientific notation format. So we talked a lot about the coefficient and what that coefficient number, the parameters that it needs to fall in to be in correct scientific notation. So what parameters does that coefficient have to fall in to be in correct scientific notation? And that's it. I'm going to go ahead and stop the recording. If you have any questions as you're working this week, please reach out to me.